My name is Augustin Popa, and I am a product manager at the C++ team at Microsoft. I've been there for the past almost 7.5 years now, and I work on a couple different developer tools. I've worked on a little bit on Visual Studio, but more recently, I'm actually working on a package manager called VC Package, and this talk is actually all about package managers. I'm not going to be talking about one specific package manager. I'm going to be giving some examples about different types of package managers that you can use in different situations, and I'll also be discussing when you might want to use one type of package manager versus another, and just what package managers can do for you as a C++ developer. And this is with a C++ context in mind, so there are some differences than if you're using some other programming languages. So I'll go ahead and start by just talking a little bit about the ISO C++ annual surveys. So every year there is a survey that goes out, and it gets posted on isocpp.org, and it has a variety of questions for C++ developers on different topics, from what you like or dislike about the language and the evolution of the language, to what are your development workflows looking like, and what are the different challenges you're running into. And the summary results also get posted publicly, but they're also used by the committee to make decisions about the evolution of the language. Since the results are public, I've been taking a look at these for the past couple of years, and there is some interesting feedback that I've seen from people who've taken the surveys. So if we look at, there's a variety of different questions, like I said, but one of the most interesting ones, I think, is which of these do you find frustrating about C++ development? And there's lots of options to select from. And you can basically say if something is a major pain point, a minor pain point, or it's just not a very significant issue. So lots of different options there, from things that take up time to things that might just be frustrating because they result in unexpected things happening that you have to deal with, to things that are just routine that you have to deal with on a regular basis. But one thing that's been consistent at least the past 3 years that the survey has been out, is that managing libraries my application depends on is actually the number one most frustrating thing about C++ development. If you're wondering what number two is, that would be build times. That's also a very frustrating one. But you can see here, consistently, it's been listed as a major pain point. More people listing it as a major pain point than the other two categories. And if you weren't listing it as a major pain point, chances are you were listing it as at least a minor pain point. And it's continuing to be so over the years. And then there's another question, which is, how do you manage your first and third party libraries? A couple different options there. You can choose to manage your libraries using a package manager, and there's a few package managers that are listed. Or you can choose to manage your libraries manually, doing things like compiling the library separately and then linking them into your project, or actually including the source code of the library as part of your build, or maybe you found a pre-built binary on the internet that you can download. There's different ways of doing it, and people can do more than one thing. So you can see here clearly by this percentage breakdown, people have been selecting more than one option for these. But by and large, the most common responses are that the people are at least managing some of their dependencies manually. But we do see as well some specific package managers coming up, specifically NuGet, Conan, and VC Package. And we also have system package managers, which is kind of an umbrella category. There's lots of system package managers, but those are also used quite a bit. But it is worth noting that there are a lot of dependencies being managed manually as well. With that, I do want to actually just call out that the ISO C++ 2023 survey is actually open right now, I think until the 25th of April. So if you have 10 minutes later, it's worth taking the survey on isocpp.org. So if you're curious or interested in providing feedback to the committee, or just taking a look even at the past surveys that have been posted there, there's lots of interesting data to look at there. So strongly encourage you to check it out on their website. But certainly contributing back and taking the 10 minutes to take the survey is well worth your time, and it'll help inform the C++ community overall about the state of the ecosystem. All right, so let's start off by talking about some problems with managing C++ dependencies. So apparently that is one of the biggest problems that people run into, but why? What are the reasons behind that? Well, one issue is ABI compatibility. In other programming languages, you may run into API compatibility issues a lot, so application programming interface issues. So if you change, for example, the signature of a function, when that function is called, and now it's expecting different parameters and returning different things and so forth, that's going to cause a break in the build, right? Like that's pretty obvious. That'll be an issue regardless of what programming language you're using, depending on how these things are implemented. And we would expect something like that to cause a break when if a library gets updated and the structure of such things changes. But in C++, you actually have to worry about more things causing breaks. That's when we get into application binary interface issues, not just programming interface issues. Within C++, you're fundamentally producing different binaries when you change any of these aspects of your project. Everything from the compiler that you're choosing to use, and of course, there's a variety of compilers being used to compile C++ code. The three biggest ones being GCC, Clang, and MSVC, but there's other ones as well. Changing the version of a particular compiler, even if you keep the actual vendor the same, that can also cause breaking changes. And it's been such an issue that, for example, for the MSVC compiler, since 2015, we've actually been maintaining binary compatibility for builds. So that if you have a library that's built as far back as 2015, and your main project is using, say, the latest compiler on Visual Studio 2022, you actually can still link those binaries together and maintain that the consistency in the ABI and not get broken. And we had to do this because it was just a very big pain point for people, because if we come up with a new compiler version that they had to rebuild all of their dependencies and their project, it was just a lot of work. So changing a compiler version can cause these kinds of issues unless the vendor goes out of their way to make sure that issue doesn't happen. And that it does take a lot of effort to be able to do something like that. And then there's other things too. If your project initially was targeting one platform and now goes cross-platform and you're building for different operating systems, well, that's going to affect it as well. You're going to be producing different builds depending on your target operating system. And the same goes for architecture. I mean, in the past, the difference was really between x86 and like AMD 64 architectures. And now we have ARM 64 that's becoming more prominent. And of course, we have a lot of embedded devices, and those have their own architectures. So there's many different ways to produce a build, and they give you different results, and they don't just work together if you're compiling under different architectures there. But then even internal library changes, there's things you can change internally that don't appear to change things on the API level to a consumer. That's depending on your library, it might look like nothing significant's changed, but in reality, just because you inlined some statements in your code, or you moved around some virtual functions, you might have created an ABI problem, and and the person consuming your library will actually run into issues potentially. So that's all of these things are things that can break the ABI, and many of these are not things that you necessarily have to worry about in a lot of other programming languages. And then we have another problem, which is dealing with version conflicts between different libraries. And this is commonly referred to as the diamond problem. And this is a basic example of the diamond problem. Essentially, what you have here is you have your project, and your project depends on some libraries. In this case, it depends on two libraries, library A and library B. And let's say you want to say, okay, I want library A at version 1.1 and library B at version 2.2. Let's say those are the latest versions of those libraries that are available. So of course you want to use the latest. So you say, give me the latest versions of those libraries. But unbeknownst to you, both library A and B actually depend on library C. You might not care at all about library C. It might be irrelevant to your to what the work you're doing as a C++ developer. But library A and B do need library C. So then the question becomes, what happens if A and B disagree on which version of C that they want? In this case, A wants version 2 of library C and B wants version 3 of library C. Well, that's a problem because you cannot just have two completely different versions of the same library in the same dependency graph. So you need a way to actually resolve this conflict. And one thing you could do is you could downgrade the version of library B that you depend on. So at some point in time, perhaps library B was using C at version 2. And if you go back to that version, then it should be fine because now both library A and B are depending on C at the same version. But this is something that you have to identify and resolve as the person who's consuming libraries A and B, despite the fact that you didn't care about library C in the first place, but now it's impacting your project and your ability to actually build successfully. So these are areas where package managers can help, and not all package managers will help here. Specifically, package managers that are uniquely tailored for C++ will help here. But it's worth calling out that the ecosystem is very diverse, and it's important to pick and choose the right package manager for the right situation. So I wanted to call out these problems in particular as things that you will see as a C++ developer, and they're problems you will want solutions for if you're going to look at package managers. So I'll give a couple of examples of things that package managers can do to help with these kinds of problems. First example here is using the Conan package manager. So I just got this basically from their documentation. In this case, what they have here is a Conan file that describes how it basically specifies constraints around when a package will work in different situations. And in this case, it's saying that the package at a particular version, so the package is called PKG, version is 1.0, it specifies that it will only support versions of GCC between versions 4.5 and 5.0. So this is a way for the package to communicate to the package manager, don't compile me with a different version of GCC because I'm not expecting to work for that. And that information itself can get propagated to the end user who can be informed about this restriction so they understand, okay, if I'm going to be picking a version of the package, I need to understand if it'll actually work with the version of the compiler that I'm actually using. So constraints like this can be specified to package managers and to end users. And as an end user, you really just have to then select the appropriate version for your situation. You presumably have certain expectations for your actual project that's consuming these dependencies, how you want to build it, and you want to make sure that dependencies will respect your own expectations there. Another interesting example, I think, is semantic versioning. The semantic versioning specification. So for libraries that use the semantic versioning, you basically have a major version, a minor version, and a patch. So there's 3 components to it. So in this example, it's 1.2.3. And if you're respecting semantic versioning, then basically, if you increment the major version, you should expect an ABI breaking change, which means it's probably going to be more painful to make your project work with that new version. That new version might have substantial changes as well. So you have to do a cost benefit analysis, I suppose, on that situation. But at least then you can expect, okay, if I change that, I know I'm going to be broken and I'm going to have to set aside more time to work on that. On the other hand, if you just patch a library and you just change that number on the right, you wouldn't expect an ABI breaking change. It should be fine regardless of whether you go back and forth between different patches. Like if you want to test out a patch that fixes some security issue or some minor bug here and there, these would be bug fix level patches. Then you should be able to do that without having to make changes to the code that's consuming into your project that's consuming this library in order to make things work. And then the number in the middle, if you follow the Semver specification, it still shouldn't break anything, but in practice with C++, it's a bit more complicated. In the Semver specification, it's really talking more about API breaking changes, and here we in C++ have to worry about ABI as well. So it's different libraries may have different preferences. Like different library authors may have different preferences on how they treat that and whether they actually respect that strictly or not. I believe I saw in the Conan 2.0 talk from last year at CPPCon, they were mentioning how there's a way to basically specify if you want your package to respect the strict Semver major version increment for ABI breaking changes, or if you also want to use the second number, the minor version, just to say, okay, if I change the minor version, that is also going to break my ABI in this case. So that's something that could happen. But if you strictly follow Semver, it really should just be the major version that does that. Now, unfortunately, many C++ libraries just simply do not follow semantic versioning. The ecosystem is very diverse, and it's been around for a long time, and libraries have been produced for a long time. And the versioning schemes that they use are kind of all over the place. Sometimes it's a combination of letters and numbers. Sometimes you're just incrementing the same number over and over again, regardless of how big or small the update actually is. That's, for example, that's what Boost does. So this semantic versioning approach may not really scale to all the different libraries that are out there. So let's talk a little bit about how do we handle the entire ecosystem? And I'll give some examples using VC package. How do we handle the fact that there are so many different versioning schemes that are used by different libraries, and there's so many open source libraries out there in the wild? VC package currently has over 2,000 unique open source dependencies in its catalog, at least in recent times. And somehow all these things just have to work together so that if you're consuming these libraries, you don't have to go through the process of manually figuring out when is my ABI going to break, when am I going to have a diamond problem, and how do I get around that, and what versions do I have to pick and choose of the different libraries in order to get something that actually results in a successful build. And there's a couple of different features that the VC package has for this. The first one is a feature we call baselines. So basically the way a catalog of libraries is represented in VC package, in most cases, it is just a Git repo. So if you're familiar with Git, it's a version control management system. And every time you introduce a change to a Git repo, you get a unique Git commit ID. And the way to think about it here is a Git commit ID for the VC package repo is like a date and time for the state of that catalog. So for example, if you would take the most recent Git commit, you will, and you get, and you do a Git pull on that, you would get all of the libraries at their most recent version that are available in that catalog. And if you go and pick something, a Git commit ID from a year ago, you'll get all of the libraries that were available a year ago, which would be a smaller number of libraries. We wouldn't have had 2,000 at that point. It would have been a bit smaller. And the versions would also be a bit older as well, because the new versions just wouldn't be around yet. So essentially, this allows you as a user to pick and choose a point in time for all of your dependencies at once, rather than individually having to go in and say, I want Boost at this version, I want OpenSSL at this version, I want a Google test at this version. You can just pick Git commit ID as the baseline version for everything. And the reason you are able to do something like this is because in VC package, you can't just randomly commit changes to a library and they just get accepted without any questions. We actually we have a CI system that runs through and actually validates that changes to these dependencies are valid and will not break the rest of the catalog. So as part of this, we build the dependency that has been changed we build it from source. And in general, VC package is a build from source type of package manager. But we don't just build the dependency that was updated. We build all the dependencies that it depends on and all the dependencies that depend on it. And we call this the cones of destruction. And we have to successfully build all of these dependencies in order for the PR to possibly be merged. Otherwise, it will just be rejected outright and it needs to be corrected. And what this does is it gives users some assurance that whatever Git commit ID they decide to stick to, they can pick and choose any combination of libraries that were available at that point in time, and they should just work. And they also don't have to worry about exactly which version do I have to pick of each thing in order to get it to work. They'll get a reasonable default. And that's basically the point of this. So that's kind of like the baseline is the base layer of how versioning works in VC package. And then on top of that, there's a couple other features. So for example, we have minimum versioning or version greater than or equals to. And what this does is it allows you to set a constraint that is higher than that baseline that you get by default. So if you want to say, well, in this case, I know I want a more recent version of a library, you can do that. So in this case, I have an example. So I have libraries A, B, and C. And basically the way it works is library A at version 1 depends on library B at version 1. Library A at version 1.1 depends on library B at version 1 again, but it also depends on library C now at version 3. And then library A at version 1.2 depends on library B at version 2.0 now, and it still depends on library C at version 3.0. And library C just doesn't have any dependencies. So that's the example there. On the right side, on the screen, I have a manifest file that's called vcpackage.json, and that's basically where you would specify as a user what your project's dependencies are. So in this case, it's specifying that the dependencies are on library A at version greater than or equal to 1.1 and library C at version greater than or equal to 2.0. And there's also the baseline. So by default, you'd get everything at a baseline. But in this case, the version greater than or equals to will supersede the baseline and will provide a higher minimum version than that. So in this case, okay, well, what would be the solution to this based on the constraints I just described? Well, in the minimum versioning, in the philosophy of minimum versioning, you will always get the lowest version that matches the constraint, unless there is a reason that we can't give you that version, like we won't be able to build your dependency graph without a higher version. So in this case, the user is requesting version 1.1 of library A. Well, then we'll have to give them at least version 1.1. We will not give them 1.0 because they requested at least 1.1. But we also won't go out of our way to give them 1.2 as they didn't, as it's not necessary. 1.1 will satisfy the constraints and still be successful here. And this also allows you as a user to not have to keep updating the version over time as new versions come out for things like, for example, if you were using the latest version all the time, well, first of all, your project might just start breaking when you try to build, if something, like an API breaking change gets introduced. Whereas if you're using minimum version, you have some stability. You don't expect things to just suddenly build because it'll always pick the minimum version unless there's a very good reason not to. So library A will be a version 1.1. You will actually also get library B, even though you're not explicitly asking for it in the manifest, because library A needs library B. Since we said we're getting library A at version 1.1, we're going to get library B at version 1.0. So that's pretty straightforward. And then for library C, the user actually requested at least version 2 of library C, but it turns out library A at version 1.1 actually needs at least version 3 of library C. So this is when we wouldn't just give you the minimum version. We would have to go to the next version that is actually satisfied in the rest of the dependency graph, because we need library A and your actual project to agree on the version of C that they want. So the best result here will be to give version 3. As a user, you're saying you're okay with a version higher than version 2. So and library A is saying that they need to have version 3 if they're at version 1.1. So you'll get version 3 of library C. And that's basically how we solve that using minimum versioning. But again, if new versions come out of libraries A, B, and C in the future, we don't expect the user, if you rerun this, we wouldn't expect you to suddenly be getting new versions of those libraries. You would still be getting the minimum versions that satisfy the constraints. And lastly, if you want to say, I want exactly a particular version, regardless of any other constraints, there's also that. It's called overrides. All package managers have some concept of this, where you can say, give me exactly this version of something, and you can pick and choose individual versions for individual packages. And it's quite typical for most package managers to say, yes, I always want individual control over each individual package to the level of specific versions, even specific patches. But what we are doing, I guess, with VC packages, we're saying we will provide a reasonable default if you don't want to be in the business of having to manually maintain all these versions and make sure everything works together, and then you avoid diamond problems and all that stuff. So we have a reasonable default, which I guess is a nicer new user experience, or for people who don't really care necessarily. They just want something that works. They're not too picky about the version. But if you do want full control, you can also do that. And if you override a version, it will ignore the baseline. It will ignore any version greater than or equal to constraints, and it will just give you that version. This only works if you're an end consumer. So if you're producing a library that goes back into the VC package catalog, then you're not going to be able to use overrides, because you can't force your own consumers to have to use the versions that you're specifying of your dependency. It's always the end consumer that has control over that version. So that's the only difference there. Whereas version greater than or equals to and baselines do work for packages that are going back into the VC package ecosystem into the catalog. And by the way, the VC package.json file exists for both producers of libraries that become packages in VC package and consumers as well. It's just the overrides that are different there. Okay, so I talked a bit about how you can deal with these different issues around C++ dependencies. And I spent quite a bit of time now talking about versioning and different solutions to versioning. But why do you even want to keep your dependencies up to date? Is there a motivation for that? And I think there's a couple of reasons why. By being able to update your dependencies frequently, you're able to take advantage of any performance improvements that are available in new versions. You're able to take advantage of new features available by those libraries that maybe save you some time, so you don't have to implement similar functionality yourself in your consuming project. You might get bug fixes that might make your life a bit easier. And perhaps the most critical reason is security. Every once in a while, we hear about a big security vulnerability and how it got exploited and how it cost some company millions of dollars, or it hurt their reputation in some way. And these are situations that we really want to avoid. And I have their screenshot. I'm kind of picking on OpenSSL just because OpenSSL, not that there's anything wrong with OpenSSL, but it is a very, very popular library with a very significant, I guess, is very significant in terms of the attack surface available to somebody that is able to exploit it, and how prominently it's used all over the web. And there have been vulnerabilities that have been discovered over time, and there are attackers that are very motivated to figure out how to exploit a library like OpenSSL and get the most out of it. Of course, you might have heard of Heartbleed a few years ago. I think that was the most serious vulnerability that happened with OpenSSL, but there have been a few others. There was actually one a couple of months ago as well. And I know that generated a huge response from certainly from the big tech companies, to very quickly patch everything that they were using, where they were using OpenSSL, and also telling their own customers, hey, if you're using OpenSSL, make sure you move away from the vulnerable version to either you downgrade back to a version that doesn't have the new vulnerability, or you upgrade to the new one that patches it. So these are things that you have to worry about when you have an attack surface that could be exploited. And with open source dependencies, it gets particularly challenging because you might not have a full understanding of that open source dependency, what the code is doing and what the new versions are introducing to that. And you also don't want to be in a position where it takes a very long time to actually update your dependencies because you have to do everything manually. That just introduces risk, and it just makes your life more painful. And it may result in you choosing not to update your dependencies very frequently, which could be problematic, or it could result in you still trying to update your dependencies frequently, but spending more time on it than you should. When it comes to something like security, for example, you probably want to respond as quickly as possible. So using a package manager can actually help you just go through this really quickly without having to worry about exactly how do I rebuild this thing, and how broken am I going to be if I change the version. And just to go over some more benefits of C++ package managers. First of all, building packages from source. So in many package managers, this isn't really an important consideration. But for C++, I think it's absolutely critical if you want to be effective. I talked about all the different ways you can break ABI in C++. In order to provide pre-built binaries of C++ libraries to handle all of the different possible configurations that are ABI inconsistent, you would need to be building for all the different architectures, operating systems, compilers, compiler versions. You would basically just end up with a multitude of different binaries, even just for one library and one version of that library. And of course, every library and every version also produces a new set of binaries for each one of these possible configurations. And you just end up with kind of just an explosion of binaries. And in practice, package managers that provide pre-built binaries tend to concentrate on a few common build configurations that their users are likely to have. But if you have anything that's a little bit more custom than that, you're probably going to end up having to build from source. And if package managers just support build from source out of the box, then that makes your life easier because you can just define exactly how you want everything to be built and make it the same as your project, including all the compiler flags, whether you want to include address sanitizer or whatever other custom stuff you want to add to it. But at the same time, there's a downside to building from source, which is it takes a long time. Remember, I said the number 2 biggest problem for C++ developers was build times. If you're building from source a lot, you'll probably be very unhappy. So package managers also do need to have a way of providing binaries when possible. And again, I mentioned like package managers may provide pre-built binaries for the common build configurations, or they can also provide some form of binary caching for even if you run a build from source the first time to get something, then that binary gets cached somewhere, and then you can just get that binary the next time. Or if you're working on a team, if let's say 10 people on a team, one person builds from source the first time and the other 9 people can just download the binary directly, and it's a lot faster that way. So you're not duplicating that effort across 10 different machines at different times. So you're not duplicating that effort across your local development environment or your CI system. At the same time, you want control and flexibility over package versions. So I use the examples of VC package where you want to be able to avoid things like diamond problems, but at the same time, you should be able to pick and choose exactly what you want when you want to. So the package manager should have some leeway to make good default decisions for you for versions, but you should also be able to jump in and say, actually give me this version and this version. Let me give you some versioning constraints or a version range that is acceptable to me. You should be able to do stuff like that in order to exercise control and really get what you want. A lot of package managers also have manifest files. I use the example as well for VC package. Conan, for example, has that as well. But what these allow you to do is they allow you to create declarative, reproducible environments. If your package manager is, or if your manifest file is very specific about what it wants, then you should be able to get the same thing, whether you're running against that file today or you're running it from 5 years from now. You don't want to be suddenly having libraries getting updated out from under you. And now you suddenly find out that the build that you thought was fine now isn't fine anymore because some library that hasn't been updated in years got updated recently. And that's why being able to set things like versioning constraints is really useful for this purpose. It's also the case that you want to look for package managers that have significant catalogs. You want them to have lots of different libraries, and you want many different versions of those libraries. In general, package managers with large catalogs are more likely to have the libraries that you want. You have more diversity there. You can really be picky about, like if you have 10 different libraries that are parsing JSON, you have a lot of options for that as opposed to having to pick the one or two options that might be available in a different package manager. So it is worth paying attention to how big the catalogs are. I will say VC Package and Conan have significantly large package catalogs for C++. And you also want an experience where whether you're producing your own libraries and packaging them into the package manager, or you're just consuming open source ones, you want that experience to be consistent. You might have your own private libraries that you're using internally within your organization that are not going to be published to the internet. And you may have open source dependencies as well. And you want both producers and consumers of these libraries to have an experience that is consistent, that they're not having to do extra work to deal with open source dependencies, for example, because that's just going to make you less likely to use those dependencies. And same thing with closed source. Like if it takes just too much effort to make your own libraries, then you might just end up falling back to other solutions like doing Git submodules, for example. And then there's offline builds. So some companies have strict requirements around things like being connected to the internet. So you might not want to be, you might want to run your builds in an environment that's disconnected from the internet. So that should still work with a package manager, depending on what you're choosing. You want a package manager that has support for offline builds, has a way to kind of cache everything locally so that you do not need to be connecting to the internet and downloading things from the internet. And you have to worry about something getting hijacked along the way and getting modified and messing with what you're trying to do. And of course, a benefit of picking an open source package manager is that there are a lot of open source contributions. C++ has an incredible ecosystem for open source. There are many, many different projects out there, and there are lots of people who are excited and motivated to contribute to C++ open source projects, and this is really great. We've certainly seen this at Microsoft. We open sourced our STL a few years ago, and it's been just a tremendous success. The community feedback has been very positive. A lot of people have been submitting PRs to contributing to the STL, and the STL has just evolved faster than ever as a result of this. So it has been absolutely amazing. It is well worth leveraging open source when you can. And even if you're just looking for libraries just to consume, libraries that are open source have probably there's probably been a lot of eyeballs looking at those libraries. There's probably been a lot of people that have been contributing to those libraries. And the overall level of development and maturity of the projects tends to be quite high because of the sheer number of PRs that have been coming in the beginning process and the conversations that have been happening about how to best improve the experience of using that library. So basically what I'm saying is do use open source dependencies if you can. All right. So a couple of situations where you might want to decide when you're using a package manager, when you should use a package manager and when you should not use a package manager. In general, if you have more than a couple of dependencies or you have dependencies of dependencies, your situation gets more complicated. You have more work to do if you're just doing this manually. And if you can find a package manager that can give you the dependencies that you want, it'll probably save you time. If you're just getting one dependency, it might not be worth the effort. There is some level of upfront cost to configuring a package manager to work for you. it might just be easier to do a Git submodule or some other approach, or you can just build it separately and link it into your project if it's something simple like one library. But when you get into more dependencies, then the more complicated your situation gets, the more benefit you get from using a package manager, because that upfront cost is offset by the cost savings you get over time in terms of how much development time you're spending on the project. And if you have open source dependencies, I've talked to people who refuse to use open source dependencies because they don't want to have to figure out how to actually build everything, and when a version changes, what actually breaks and what they need to do to handle it. But it, like I said before, it's well worth leveraging the many thousands of open source dependencies that are out there that solve many of the common problems that you'll be trying to solve as a developer. And it's typically easier to install these from a package manager. In particular, if there are system package managers that cover many of the big open source dependencies, but also the language package managers like VC Package and Conan have extensive catalogs of open source dependencies that make it trivial to integrate these into your project, at least compared to having to go into the GitHub repo of that dependency, having to figure out how to build its dependencies, how to integrate it into your project, depending on what build system you're using and so forth. You just save a lot of time by using a package manager. And then other situations, a package manager makes it easier to think about incorporating dependencies that actually have to be linked into your project. I've seen people argue for header-only dependencies just because it's easier. You don't have to worry about ABI, for example. But that's not really ideal. If you have a really massive header-only library, it's not really doing you any favors. So rather than saying, oh, I'm just going to make my library header only, maybe you can not make it header only, but then make it available via package manager. So it's still easier to consume, but it gets the benefits from being a linked library rather than a header only one. And in general, maintenance times, if you care about maintenance time and security, package managers can definitely help you there. Okay, just quickly spend some time talking about modules because modules are a hot topic nowadays. So modules do address some issues that come up with C++ development. They're certainly one of the biggest feature improvements to the C++ language, helping with a variety of things like overuse of headers during pre-processing and macros, using declarations, some ODR violations, even just general cleanup things like not having to have the separate header and source files in your repo, basically just doubling the number of files that you have. And having the code architecture just be clear with separate logical components. These are all things that modules are just great with. But they still won't really fix some of the fundamental problems that I talked about earlier. If you want to maintain ABI stability, if you want to avoid daemon problems, and then there's also the issue of how do you actually get all of the libraries that exist today migrated to modules. It'll probably still take a long time for that to happen. I mean, we've only recently really completed implementation of module support by some of the major compiler vendors, and we still have to worry about migrating the entire ecosystem of libraries to use modules, whether we're talking about internal ones or closed source ones being used by companies, or we're talking about open source ones. There's a lot of work there. So regardless, we do still need, modules are not the one fix to rule them all kind of solution. They help us in a variety of important ways. You should use modules if you can, but don't expect that means you don't need to use a package manager and you will just be fine. There are still benefits to using a package manager even with that. So with that said, I talked a lot about package managers, but what are the different types of package managers that are available? And I categorize them into three options here. So first you have system package managers, which are, as you might guess, suited to a particular system, like an operating system distribution. Then you have language package managers. The language package managers are suited to a particular programming language. Now, I call out the C++ ones separately, and there's a lot of C++ language package managers actually, but the two biggest ones by far, at least in the survey responses, but when asked what people were actually using, were VC Package and Conan. Whereas for system package managers, you have things like the Ubuntu package manager, apt, RPM, Yum, Pacman. But then you also have the third category, which is still language package managers, but they're not actually C++ package managers. And you might be wondering, well, why would you even use these if you're a C++ developer? And there's actually reasons why you would. So those are the language; those are package managers like NuGet, which does show up quite a bit in the survey, NPM, Cargo, and so forth. And I'll talk about each one of these and kind of differentiate them a little bit. Okay, so starting with system package managers. So, like I said, they're designed for a particular operating system distribution. This has pros and cons. If you are primarily sticking to one system, if you're building for that system, if your project is going to run on that system, then a system package manager may be sufficient. System package managers can give you a variety of different packages for that system, not even just libraries. You can get all kinds of tools, apps, and other things for any kind of workload. They're also not restricted to just C++ either. So you can have a consistent, basically use the same package manager, even if you're using a variety of different programming languages. They're most well known perhaps on Linux distributions, but they're certainly also there on Mac OS and even Windows. I mean, you have Chocolatey and WinGet now that would be considered system package managers. Packages are often installed system-wide and usually require elevation. So this may be an issue as well for some people. Sometimes you might want an Xcopy deployable package rather than having to go and authenticate all the time to show that you have the right permissions. And then there's also a question of what happens if you want multiple versions of the same package installed. Like maybe you're testing out the pre-release version, but you're also using the stable version primarily in production, but you want those to exist side by side on your system. So sometimes that's a bit trickier with system package managers because of that system-wide restriction. And there's also the question of what happens if you go cross-platform. So we've seen a trend in the past few years of people increasingly targeting more than one platform. This is, I think, part of the reason CMake has become so popular. But it's also an issue if you're using a system package manager, because now your system package manager is not going to help you if you go to a different system. You're probably going to have to pick a different system package manager for that system, or you'll have to pick a solution that just isn't restricted to a system. So that's something that you need to be careful with. And then there's also how well do system package managers integrate with build systems? That varies. Your miles may vary there. System package managers tend to install to well-defined paths. So you can expect your compiler to go in a certain place and expect your libraries to go in a certain place. And build systems may be able to leverage that and use those defaults to just work. But sometimes you might run into some issues and things don't work quite as expected, and you have to do a little bit more configuring to get everything to work correctly, to get your development process up and running. All right, and then the next category is C++ language package managers. So specifically calling out VC Package and Conan because they are the two biggest ones. Again, I work on VC Package, just full disclosure, but both of these are great solutions. I think that they both came out in 2016, and they've been evolving ever since. There was a talk a couple of years ago on C++ package managers at ACCU. And it actually spent a lot of time comparing VC Package and Conan. And I just want to call out, even from a few years ago, both of these products have evolved a lot since then. So even if you're watching the talk from a couple of years ago, just keep in mind that there's new functionality and new problems that have been getting solved by these package managers. So it's well worth taking a look at perhaps at their documentations and just comparing and seeing what has changed in the past couple of years, because it has changed quite a bit. Certainly their catalogs have gotten a lot bigger. That's one of the big things, but even the features have. So C++ package managers are tailored for C++ development. Rather than being specialized for a system, they're cross-platform, but they're specialized to C++. So if you're doing non-C++ stuff, you might not get much mileage out of it. But they do have solutions to some C++ specific problems. They do look at things like how do I solve version conflicts between libraries? How do I deal with ABI breaking changes? How do I understand when this problem is when I'm about to run into this problem, and how do I get around it? These are things that are really carefully considered by design by these package managers, and that's what makes them so powerful. They also support building from source, which again, as I mentioned before, I think that's a critical consideration if you want to get around ABI issues. You need to be able to customize your package by being able to build it from source how you want to, how you build your actual project. You want everything to be built consistently. While at the same time, if there is a valid pre-built binary that exists, you can just download that and not have to build from source if you don't have to. So build from source gives you flexibility. Downloading pre-built binaries saves you time, and you have both of those available with these package managers. Both of these package managers have very large catalogs of libraries. In VC Package, it's on the github.com/Microsoft/VC Package. On Conan has Conan Center. If you're looking to get open source libraries, you will find probably everything you need if you go looking with these package managers. There have been a lot of community contributions over the years. Really, most of the PRs coming in, they're not coming just from the maintainers of these libraries. Most of the PRs coming in are from the wider C++ community that are passionate about these projects, have been contributing to these projects. And I think this is really showing in just how much these catalogs have grown. But while they support open source, they do work with closed source as well. You can make your own libraries and package them for use with these package managers. And then you have the same workflow. So you can consume packages, whether they're your own libraries or they're open source ones. And packages don't actually have to be libraries. They can be a variety of things. You can consume build tools, SDKs, debuggers, whatever tools you need for a working development environment. There are ways of consuming those or publishing those through these package managers as well. I will say for VC Package, it's a bit newer. We have a feature called VC Package Artifacts that deals with this kind of world, and that's still something that's being actively worked on. It's in preview currently, but that is an option that is out there for pre-built packages that are not libraries, and you don't need to build them from source. And because C++ is a very cross-platform, cross-architecture, multiple compiler ecosystem, these package managers have to understand that world and actually work within it. So if you're targeting a variety of platforms, architectures, compilers, even if you have something more niche that you're picking, there's a way to get it to work with the package manager. And even if by default it doesn't give you the specific like embedded architecture, for example, that you might be targeting, that doesn't mean you can't extend it and add your own integration for that. In Conan, I believe they have build profiles. In VC Package, we call them triplets. You can customize your build however you want to, but you also have reasonable defaults available, so you don't have to do the extra work of customizing if you're just doing something that's very typical. Okay, and then non-C++ language package managers, so NuGet, NPM, Cargo, pip, etc. NuGet was the only one that really came up prominently in the survey. There are situations where you may want to get a C++ dependency, even if you're not primarily a C++ developer. So sometimes you might be a .NET developer, but you have a C++ library that you use, and then you do C++ CLI. You use C++ CLI to kind of combine the two worlds, and you can have that native dependency in your managed project. So there's situations like that happen. We've also had people, for example, who needed the MSVC compiler, but they're really Node developers or Python developers, and they just have to build something that they need as a dependency for their project. But primarily, they don't really do much C++ stuff. These are the kinds of situations where you'd be using a non-C++ package manager, because that is the package manager you would already be using as a developer in that language. If you're a .NET developer, you should use NuGet. If you're a JavaScript developer, use NPM. If you're a Rust developer, use Cargo. It makes sense. You should use a package manager that is focused for that language for the same reasons you would use a C++ package manager if you're primarily a C++ developer. So there are situations like that where you may want to do that. There are quite a few NuGet C++ users, even developers that have a lot of C++ code. There are quite a few of them that do use NuGet. I will point out that NuGet is a .NET package manager. There are several areas that it just doesn't address for C++. It doesn't really address API violations and diamond problems. It doesn't build from source. It doesn't have an easy way to really manage to really specify, okay, this package should work for this architecture or this operating system or this compiler version. You basically end up just like modifying the package title and making it like .x86.windows something, just to clarify to the consumer that is going to take that package in what the package actually does. Because it's really not designed around stuff like that. It's a .NET package manager. It's also tied to the MS build system and primarily Windows, although you can use it outside of Windows, but in practice, it's probably used mostly on Windows. So just keep that in mind if you're considering NuGet, that there are restrictions there as well. And you can use, if you have both NuGet, or if you have both .NET and C++ dependencies, you can use NuGet for your .NET ones, and you can use a C++ package manager for your C++ ones. So in general, what I'm trying to say here is, if you're primarily not a C++ developer, then sure, use one of these package managers, and you can figure out how to get C++ dependencies to them as well. There are some C++ dependencies available by default as well on some of these package managers. But keep in mind, your experience will be limited, and it's not ideal. If you're doing a lot of C++ development, you probably should pick a C++ package manager or a system package manager, if that makes more sense. So if you're working primarily in one system and you don't update your dependencies frequently, a system package manager will work just fine. It's probably all you really need. And you will probably be familiar with it because you're already using that system. In addition, if you need something that's very niche to that system, like a graphics library that only runs on Linux, for example, it may be the case that the system package manager is more likely to have it than some other package manager. So consider what packages are available in the catalog and whether it has everything that you need to run on that system. System package managers are likely to have what you need to run on that system. But if you primarily work in another programming language and you want the best experience for that programming language, then use that language's primary package manager. And if that language happens to be C++ that you're primarily using, then do use a C++ package manager. It'll help you deal with API issues, diamond problems, and you get a wide variety of C++ packages. By far the largest catalog sizes available if you're looking at VC Package and Conan. And it's great if you're installing per project dependencies so that other projects can have separate versions of the same dependencies. You're not installing things system-wide. You don't need to install things with elevation. So if those are concerns for you, then that's where a C++ package manager is great. All right, and I'll just quickly cover reproducible development environments. So if I mentioned this briefly, package managers that have a support for a manifest file should be able to give you some level of reproducibility. As long as you don't modify the manifest file, you should get the same thing, whether you run the package manager today against the manifest or you run it at some point in the future. And you can, and if you also extend beyond just packaging libraries, if you package tools, you could potentially get your whole development environment configured through a package manager. It might be a bit more effort, depending on the level of support the package manager has, but that's something that you can do. But if you do want to get a whole development environment built from scratch, and you're also just sticking to one system package managers have been doing that for a long time, so they'll be great for that. But there have been investments as well, like both VC Package and Conan have been getting into this space as well, and being able to bootstrap your development environment and get developer tools like compilers, not just libraries as well. So you'll want to compare and contrast them and see what works best for you. Okay, and yeah, so that covers that slide. So just some principles to keep in mind about managing dependencies well. First of all, for a good C++ experience, you want to be able to build dependencies from source when necessary. But if it's not necessary, then you should have a way to get the binaries, assuming that you have a way of actually verifying that the binaries will be appropriate and will not cause an ABI mismatch with other dependencies that you have or with your consuming project. Again, package managers are C++ package managers are designed to solve these kinds of problems. It is okay to use more than one package manager. I've often heard conversations the past few years about, can we have one package manager to rule them all? One unified package manager for everything that you might need on any system, on any programming language. I have yet to see even a successful design for one being planned. I think the scope of such a thing would be incredibly difficult to deliver on. And we certainly don't have something that works universally today. I'll talk in a follow-up slide about something we tried to do at Microsoft around that and why it didn't exactly work. But I'll get to that when I get to that slide. And then other things, keeping your dependencies up to date is important. I've talked to many developers that have dependencies that are months or years out of date, and that's been an issue for us at Microsoft for a long time as well. That's something that we want to move away from. We want to be able to use the latest versions of any dependencies because you get the latest and greatest things by doing that. You can also avoid security vulnerabilities and so forth. But of course, that means the process for updating them needs to be good, and package managers can help with that. When you have a package manager, there's not just a consumption experience, but also the production experience. It needs to be straightforward to actually produce packages or produce something that you're going to give to somebody else to use. So that workflow is also something you want to pay attention to. And package managers have, like, half of the package manager story is what that workflow will look like. Do keep in mind as well which platforms you're targeting. If you're going cross-platform or thinking about going cross-platform, that affects the complexity of what you need to do. And you might want to use C++ package manager if cross-platform is a consideration. And in that case, system package managers might also be more of a detriment than a help, depending on what you're doing. Do take advantage of open source. Do work on making your build environment reproducible using manifest files, and do enforce ABI requirements across any dependencies that you have in your dependency graph, because you don't want unexpected surprises if someone makes a change and suddenly the whole build fails. So those are all principles that to keep in mind. And again, package managers help you maintain these principles. All right. So this hopefully is not a controversial statement. C++ package managers should be accessible and productive for all C++ developers. That's what we want. And I think over the years, they've gotten better and better at this. If you last took a look at C++ package managers a couple of years ago, you should take a second look and see where they are today. A lot has changed. The ecosystem has just gotten better and better, and I think we're way better off than we were even 2 or 3 years ago. So just keep in mind that if you're running into issues managing dependencies, you're definitely not the only one. Lots of people are running into the same issues, and these package managers have evolved to try to solve these problems for everyone. All right, and let's talk a little bit about Microsoft and what we do at Microsoft for dependency management. So there are many different teams at Microsoft. It's a large company. We work on a variety of different products and services, and in a variety of different programming languages as well. But there's quite a lot of C and C++ code at Microsoft. There's a huge amount of it, just incalculable, really, just how much code is written in C and C++. And different teams would have their own solutions for dealing with dependencies for C++. Typically, we would have each team would decide what worked best for them. Some teams would use Git submodules. Sometimes they would make their own package manager, and they would have a dedicated team of people that maintains that package manager for use for that team. Sometimes they would just build dependencies separately, linking them to the consuming project. They would definitely be a very different experience for consuming open source versus non-open source dependencies. And some teams would just avoid open source dependencies altogether just because of the extra pain involved, having to understand the code base, having to go through all the compliance checks, having to basically figure out how to get everything working and how do you actually update those dependencies and what happens if a vulnerability gets introduced and you have to react really quickly to that. That's just additional pain that would get introduced. And every team would end up doing basically whatever worked best for them. Sometimes dependencies might get months or years out of date if they were dependencies that weren't considered critical. And that meant that you're just kind of stuck on that version, despite knowing that a new version came out that has something better that you could have leveraged, but it's just too much effort having to update that dependency. We had this a lot with compiler versions as well, where upgrading a compiler version is no small feat. So you have to be very deliberate and careful, and so it's had a lot of time to actually do that and make sure that everything still works at the end when you're done. So there has been a lot of transitioning at the company. We have an organization in Microsoft that's basically dedicated to trying to standardize engineering processes across the company. And more teams have been joining this effort and trying to consolidate and decide as a group what are the best development workflows for us and that we can use across the company. And this has resulted in, for example, people consolidating on what IDEs they're using, what compilers they're using, where they're running their CI, what cloud services they're using, a variety, what kind of testing procedures they're using, adding things like address sanitizer integration and using that deliberately as a part of a testing process, but also package managers. So there has been a massive surge in teams adopting VC package, for example, at Microsoft. And a lot of investment has been made to make that a reality. And the result of that is we've been able to save massive amounts of development time by kind of centralizing around tools and services that typically are also available publicly. So they're not internal only. They're things that are also available, often open source projects as well. And that also are things that solve problems that are common across the organization. So in the case of a VC package, what they basically did is they've been looking at things like they created a mirror of the open source catalog that VC package provides, and that mirrored catalog goes through all these extra compliance checks that are needed internally at the company, and also allow them to centrally control which versions of packages and which packages are actually available to developers within the company. So if you want to say, don't use the vulnerable version of OpenSSL, you can just exclude it from the catalog and make sure nobody can actually try to reference it. It's also good for just in general for making sure that we're meeting all our obligations and still being able to take advantage of all the features available to the package manager that anybody can use, whether you work at Microsoft or not. It's the same product. It's the same user experience. And of course, by using a package manager like this, you also have first-party and third-party dependencies being treated the same way. So if you want to produce your own libraries, you can still use them with the package manager. Or if you're not, if you're using open source dependencies, it's the same process. And it's managing it is as simple as having a manifest file in your team's repo, which describes all your dependencies and what you need, basically. In the past, we had a very popular package manager that was used internally at Microsoft that really used very widely across the company, that was trying to act kind of like a universal package manager crossing different programming language boundaries in different systems, and just being able to bootstrap your development environment and also get you the libraries that you need so that you can just go and hit build and then everything just works. But because this was an internal only project, it created challenges because it just didn't have the same level of, it was very difficult basically to scale the investment into that project so that actually continue supporting all the different teams that were actually using it. So we've been moving more and more towards using open source software, often software that we're also maintaining, because open source projects just move very, very quickly. They get a lot of support from the wider community, and it just really helps. So that's one of the reasons I think why VC Package has been so successful being adopted at the company. All right, and lastly, I just wanted to say, if you like contributing to open source, do consider contributing to an open source package manager. And if your organization or is currently working with an in-house package management solution, consider whether it might be better to actually spend the time working with an open source solution. Because certainly at Microsoft, we found that working with open source projects, we can still contribute to them. We can still help them evolve in ways that benefit us as when we're using them. But we're not the only ones contributing to them. It's not just your organization that's contributing, it's the world. And that allows that tool to grow at a much faster rate. And you also learn things from people from different companies that are contributing to this thing, and learn different workflows and get ideas about how to best be successful and productive. So just wanted to put that out there. And that brings me to the end. So for the rest of the time available, I'm happy to take any questions. And thank you for listening.